Hello and welcome to Mrs. Law's class. In this video, we're going to take a look at how to identify misleading graphs and why people create them. Now, distorting means to change the appearance or the meaning of something in a way that is misleading. Misleading graphs can cause people to misinterpret the data and then draw false conclusions. So we're going to take a look at different ways that people can actually create misleading graphs. And the first one is distorting the scale. One way of distorting the scale is to create a displaced axis. And this is where the numbers on the axis do not actually start at 0. So here's an example. Taking a look at the bar graph to the right, we can see Matthew's math test scores. So what's our first impression of the graph? Well, it seems like from test 1 to test 2, he's made a significant improvement. So he improved a lot from test 1 to test 2. Now, what part of the graph has been distorted to create this impression? So if we take a look at the y-axis, we do start at 0, but then there's a jump from 0 to 60. But then the jumps after that are only by 2. So this is not an even scale. So we call this a displaced axis because instead of having the x-axis way down on the bottom, where it actually does start at 0, it's actually been moved up to maybe, say, 58. So the y-axis has 0, but the graph doesn't actually start at 0. So there is a jump from 0 to 60 that is not consistent with the rest of the scale. Oops. So what test scores did Matthew actually receive? So we can take a look on test 1. We look across and he actually got 60. On test 2, we look across and he got 65. In test 3, he got 68. And then finally in test 4, we look across and he got 69. So why is the graph misleading? Well, when we take a look at the bars actually represent absolute magnitude because they're filled in. So it actually looks like that Matthew did 3 times better on test 2 than he did on test 1, because if we stack 3 more of these squares on top of each other, we get test 2's score. So bar graphs, they emphasize absolute magnitude. So it looks like Matthew did 3 times better on test 2 than test 1. When you take a look at the scores that we did in part C, he actually only scored 5 marks better. So he only scored 5 marks better. So how can we now make the graph less misleading? So we're going to draw the new graph, and what we're going to do is we're actually going to start at a scale of 0, and then we're going to skip count by tens and then be able to draw the entire bar. So I'm going to pause now and draw the graph. And you can do that as well. So you can see my graph to the right includes 0 on the y-axis, and I've increased the increment equally by 10. Don't forget to write a title for your graph and also put labels for your y-axis and also your x-axis. Now next, we're going to take a look at another way to distort the scale, which is by creating an irregular scale. This means that the spacing between the numbers on an axis is not consistent, and this can occur on the y-axis or the x-axis. Let's take a look at an example. So the graph to the right shows Levi Tate's skateboard sales. On the x-axis, we can see that it increments equally, 1, 2, 3, 4 every week. On the y-axis, however, if we start at 0, we increase by 1, and then 2, and then 4, and then 8, and then 16. It looks like the y-scale is actually doubling every time. So what we can say is that the dependent axis has an uneven scale. So what impression does a misleading graph make? Well, it looks like the jump from week 1 to week 2 is 3 squares, so that makes it look like it's the same from week 3 to week 4, which is also 3 squares. However, when we take a look at the dollar value, the week 1 to week 2, this is only an increase of $700, so from 1 to 800. And then from week 3 to week 4, this is actually from $400 all the way to $3,200, which is actually a $2,800 increase. So it makes it look like the jump from week 1 to 2 is the same as week 3 to 4. Now I'm going to write the numbers in reality. So week 1 to week 2 is actually $700, and then week 3 to week 4 is actually $2,800. Now why would someone want to do that? Well, probably to show maybe that it's consistent. So we can see that the graph has the same 3 jumps, the same slope actually. So the person might actually want to show that, hey, you know what? Our skateboard sales are always the same, and we're always doing very well, even though there might be a little dip from week 2 to 3. Now, how can the graph be redrawn so that it is not misleading? Well, simply we can redraw the y-axis with an even scale. Now, we're actually not going to do that here, just for time's sake, but you can actually redraw this graph so that on the y-axis, maybe you can increase by 2 or even 4. All right, let's take a look at another way to create a misleading graph, and that is by an exaggerated use of area and volume. So this is where the heights and our widths are not consistent from bar to bar. So when we take a look at this example, we can see that the bars are definitely misleading because the desktops are very wide and the laptops, the bar is a little bit narrower. So the bar for desktops is wider than the laptops. So when we think about it in terms of area, I feel like the laptops, we can actually put 4 of these bars into the one bar of the desktops. However, when we only look at the numbers, we can see that laptops, the serial was 2,000 sales of laptops, and desktops, there's actually 4,000. So the desktops are actually only double the number of the laptops, not 4 times. So to add on to our explanation, we can say that the bar for desktops is wider than the laptops, so it looks like there were 4 times as many sales, but it was only 2 times. So what should the graph look like? Well, we should always draw the bars with the same width. So draw the bars the same width. All right, we're going to take a look at one more way to create misleading graphs, and that is by the Deceptive Pictograph. So this is where pictures are different sizes. So you can see this graph to the right. We have favorite pets of grade 8 students. So first question is, which pet seems to be the favorite? And explain. So when we take a look, it seems like the fish is the most favorite because it is the longest graph. So fish, because the line for fish is the longest, and also because the symbol is the largest. Now, from the pictograph, does it seem that more students like cats or dogs? And explain. Well, when we take a look, we can see that the length of the dogs is longer, so it seems like more students like dogs than cats. So it seems like more students like dogs than cats because the line for dogs is longer. All right, finally, how should the pictograph be redrawn to represent the data more accurately? So simply, we need to keep all of the symbols always the same size, and we also want to space the symbols an equal distance apart from each other. So keep the symbols the same size and space the symbols the same distance apart. And that's how you can identify some misleading graphs.